Hi there. Today we're going to be talking through the Data Quality Assessment, or DQA, Accelerator from West Monroe. The Data Quality Assessment tool boosts analytics and decision-making by ensuring your data is accurate and reliable, leading to informed choices, effective risk mitigation, and a competitive edge. Enhanced data quality enables personalized customer experiences, building trust and increasing loyalty and satisfaction, which aids in retention and acquisition. Additionally, our tool helps you stay compliant with industry regulations, ensuring audit readiness and protecting your reputation. The Data Quality Assessment, or DQA, is executed in 3 phases. We begin with deployment and configuration, where a Databricks code base is deployed on any of the major 3 public clouds. Then, DQA is executed and delivers a comprehensive assessment, including data profiling, validation, schema enforcement, automated format compliance, and automated duplicate detection. Any of these 5 can be chosen or turned off. Finally, output and remediation compiles all of the above results into a business-ready Excel document to expedite the remediation process for business users. The DQA allows clients to overcome the challenges of traditional data quality remediation. Unlike traditional methods that are manually intensive, costly, and time-consuming, the DQA offers effortless automation by leveraging GenAI for automatic quality identification and first-pass analytics. This approach is cost-effective, utilizing efficient processing that's intuitive for users at any experience level. Now we will jump into Databricks, where we will delve into a dataset that represents the complexities faced by our hypothetical client as they prepare for a significant data migration. The dataset we're seeing here encompasses all the account records from our client's CRM. Each record in this dataset should represent a unique legal entity that our client does business with. The detail of each record includes information like a company name, street address, city, phone number, and the number of years since the account was opened up. Our client is preparing to transition this data into a new greenfield instance, necessitating a comprehensive data cleanup. To ensure a seamless migration process, they seek a deeper understanding of their current data landscape and any existing technical debt. Their primary concerns include 1. Column-level data integrity, 2. Duplicate account record identification, and 3. Address consistency for a future API integration. To address these challenges, the client has engaged West Monroe. We recommended our proprietary Data Quality Assessment tool, or DQA, as the ideal solution to tackle these issues efficiently and effectively. Now we'll jump into the DQA Orchestrator tool and talk more about the problems that our client is facing, and specifically how the Data Quality Assessment can help to mitigate these problems. Firstly, the client is particularly worried about the integrity of their data at the field level. They need to comprehend the composition of each column. For instance, a known automation bug in their legacy system occasionally causes the years since opening field to not be populated. As this field is mandatory in their feature system, the client requires clarity on the extent of this issue, specifically on the number of null entries. To resolve this issue, we will use Feature 1 of the DQA, which performs data profiling on each column within the table. It basically takes all of the data and profiles it at the field level to provide high-level insights into the data. To activate Feature 1 of the DQA, we will need to set up the parameters. In order to do this, we will turn the active flag to true. This is one of the great parts about the DQA, is that we are able to turn on and off individual features of the DQA. For example, for our use case here at this client, we will not be needing data profile validation, nor will we be needing RLV or record level schema enforcement, so we will turn those off. Another concern that the client has is in regard to the presence of duplicate accounts within their legacy account ledger. Ideally, each record should represent a unique client. However, due to manual data entry by their employees, the client suspects the existence of duplicates, including potential misspellings and discrepancies. They aim to identify and rectify these duplicates prior to migration to prevent complications in the new system. To combat this issue, we will be leveraging the automatic duplicate detection feature of the DQA. We will turn this on with this parameter here, and we'll provide a list of columns here that will allow us to specify what makes up a unique record. In this case, they are companies, so we will include the company name, street address, and city. If all 3 of these can be fuzzy matched to another record within around 75%, we will consider this a potential duplicate. This will allow us to pick up not only exact matches, but also potential slight misspellings. If all 3 of these match, then we will consider this a potential duplicate record and raise the flag to the business users. We also have the ability to run a GenAI critique over the deterministically evaluated records. That can be found here, and we can turn that on or off. As a quick note, this is our first use case involving GenAI in the DQA. For this deduplication tool, the use of GenAI is optional for our clients to use. West Monroe strongly recommends it, though, due to its ability to significantly improve accuracy and reduce manual review time, thereby delivering faster results at scale. The intent is to deploy GenAI as a first-pass data analyst that can review through nuanced deduplication activities and find traditionally difficult to detect duplicate entries. These advantages come with robust confidentiality and the security assurances inherent to modern GenAI applications. However, it is important to note that our clients must provide explicit approval before GenAI features can be activated. And to ensure data integrity, all GenAI applications at West Monroe incorporate a human-in-the-loop approach. This means that GenAI never alters data directly. Instead, a human must review and approve any GenAI-suggested changes, maintaining compliance and trust. These suggested changes will be clearly visible in the final business-ready Excel sheet that is produced at the end of the DQA. In this particular case, our client has provided us approval, so we will use the GenAI critique. And finally, we'll talk about their third concern, which is address consistency. Because in the future state, an API connector will necessitate the use of an abbreviated address. For example, street must be abbreviated as ST. Currently, addresses are manually entered by sales personnel, raising concerns about consistency. The client seeks a high-level overview of this issue, but they have limited technical resources right now to identify all possible abbreviations and develop the necessary scripts at scale. To address this concern, we will use the automatic formatted compliance feature of the DQA. In order to use it, we will set the active flag to true, and we will next have the ability to set our sample percentage. This is an extremely useful tool for taking a small sample of randomized records, especially for extremely large datasets. In this case, though, we want to perform format compliance on the entire dataset, therefore we will use 100%. The final parameter that we will be able to set is the fields to adhere option. In this case, we are able to specify a specific column and the format correction that we would like to have applied to that column. In this case, we are going to select the street address column, and we are going to provide the following prompt. Assess street addresses and return true if the address ends with a properly abbreviated suffix or has no suffix needing abbreviation. Return false otherwise. For example, accept 123 Main Corner Street, but not 123 Main Corner Street. In this way, the DQA allows us to ask big and nuanced questions about our data on a per-record level. And on the output side, in the DQA Excel sheet, it will provide a comprehensive list of all those street addresses that failed the validation and provide in plain English how each record can be brought into compliance. Now that we have set all of our parameters, we will now begin to run the DQA. We will start off with the data profiling feature, which we can run here. The next feature that we need to run is the automated duplicate detection feature, which we can run here. What we'll notice here after a few seconds is that the GenAI critique, since it's turned on, executed, and it only took around 2.5 seconds. And after another minute or so, we can see that the output has now been complete, and it has produced an Excel sheet that will be captured in a comprehensive output sheet later. The last and final feature will be the automated format compliance, which we can run here. Of this, since we're processing 100% of records, it will process all 952 records. After another minute, we can see that our process succeeded. And in our analysis, out of the 952 original records that were analyzed, there was a compliance failure rate of 28.78%. We will be able to explore these records more in the final Excel sheet that we'll review in just a moment. The last step in the DQA process is to combine all of the previous Excel sheet results into one. Now that the DQA is completed running, we can take a look at the output sheet, and you'll notice that there are now 3 tabs in this Excel sheet. We have data profiling, format street address, and automated duplicate detection. These are the 3 features that we ran, and they were all compiled into a single Excel sheet for business users for this table. We'll start with the data profiling page, which gives us facts and statistics about each column in this table. For example, in row 8, we have the years since opening account, and the related statistics that go along with this. If we use the use case that the client provided us earlier, they were concerned about a bug that wouldn't populate this field. And we can see is that we have 8.82% of the records in this column are null, meaning that the bug affects 8.82% of their records. The data profiling page also has additional statistics like minimums, maximums, and averages, which can be used for outlier detection to make sure values are in the expected ranges. This can be seen here, where we have an average value of 19, meaning that the average customer has been with the firm for around 19 years. The next output that we'll take a look at is the automated duplicate detection output. In this output, we have identified groups of potential duplicates. We can filter into individual duplicate groups using column A, which is the duplicate group ID. We can select a particular group, for example, group 1. In all three of these cases, we have the company names, and all three of them are very similar to one another, but they have misspellings. Same thing with the street address. None of these three things are spelled correctly, but they are likely similar to one another, which is why they were caught by the DQA. If our hypothetical client was to want to merge all three of these records into one golden record, they need to figure out which one of these is in fact the golden record. In order to find this out, we will need to go take a look at the metadata that is contained in the right-hand side of this Excel spreadsheet, which is populated by the DQA. We can take a look here that, for example, we have overall loan totals and the last modified date of each record. This additional metadata is pulled from elsewhere in the data model. For example, the overall loan total is the loan amounts that are linked to this account in the loan object. The reason we will pull this information in is so that the business decision maker who is using this data can determine which of these accounts is most likely the golden record. In this case, we can see that the middle record here has a $1.2 million loan total, and the other two only have an $80,000 and $20,000 respectively. Therefore, in all likelihood, the middle record here is in fact the golden record. Therefore, we can use the provided metadata mapping fields to say that the middle record does in fact survive, and the other two records do not survive. The final output that we will address is the format adherence output, which emphasized abbreviated suffixes. The output highlights all of the records that failed the formatting check, showing the original record on the left-hand side and a clear explanation of the issue on the right-hand side. In this particular case, this address had a failure because street should in fact have a abbreviated suffix, ST. And in plain English, the DQA is able to summarize exactly what the problem is, so business users know exactly how to remediate the issue. Overall, this tool empowers business users to ask nuanced questions of their data and gain actionable insights for compliance, effectively applying format adherence at scale. It also identifies potential address formatting issues that are often overlooked. All of this is able to happen without requiring extensive research into proper address formatting rules or technical resources to develop scripts. To learn more about the DQA or West Monroe in general, please reach out to Nick Bouchard or Robin Van Overbeck. Thank you.